Okay, great. We can get started. So my name's Neil Padgett. I'm a program manager working on the Microsoft Sync framework. And today I'm going to talk a bit about the framework and why you'd want to use it, why you want to take content offline. And then we'll look at how you can use the framework, and we'll talk about a protocol called FeedSync, which is an open protocol that extends RSS and Atom to enable synchronization. Then Pablo's going to come up and talk a bit about something we're calling Astoria Offline. And then I'm going to talk a bit about how Sync fits together with SQL Server Data Services, another talk you guys may have seen earlier. So there's an interesting question of why exactly would we want to take content offline? A lot of us sort of think, well, connectivity is ubiquitous. It's everywhere. I have my smartphone. I can take data everywhere. But anyone who's owned a smartphone learns pretty quickly that connectivity isn't as ubiquitous as you think. And that's why we start doing things like taking email offline. And in fact, we end up finding that we want to do this for a lot of data. So people say, I have a line of business application. I want to take this data with me. And at the same time, we see more of these devices coming into the marketplace. So you see the statistic there. People are buying more portable PCs. In fact, we also know, in fact, that many users are considering a portable PC as a second PC, or in many cases, they're replacing their desktop PC with a portable PC as their primary PC. We see this with consumers, and we also see this in more traditional areas where laptops are sold, like Salesforce and mobile worker scenarios. At the same time, too, the smartphones I talked about are starting to sell extremely well. By 2010, projections are saying upwards of 1 billion units will be sold. So we have a lot of these. And at the same time, like I said, that connectivity just isn't there everywhere yet. It's in the major metros, but even then there can be spots of non-coverage. There are scenarios where you're in an airplane, where you're on the go. And people want to have that data with them when they want, not just when the network's available. So how exactly do we say, OK, I have content and I want to take that offline? Well, fundamentally, the core problem we have is one of synchronization, which is I have some data, and I want to keep a local cache of that data in sync with some other remote endpoint or some other remote endpoints. So this is one of those things that starts to sound easy at the beginning. You say, OK, I'll just take the data over there and move it over here, and be good. But then you say, well, we have problems where people aren't going to be disconnected for a long time. You may have people on different endpoints making changes. And you start to see things like conflicts arise. At the same time, you have problems where networks are unreliable or workers need to go now and they pull the plug during a sync operation. And there are interruptions. And these sorts of things are what end up making a sync solution hard. So sync is one of those problems where the devil is so much in the details. And it seems easy at first, but once you start to delve into the corner cases, you realize that it's not so easy as you thought. And that's where the sync framework comes in. So what the sync framework is a library that bundles up the logic that handles all those tricky corner cases. And instead, you supply code that lets you talk to your store, and we handle the aspects of data synchronization. We'll talk about this more in a bit. I want to talk a bit more about why you'd want to synchronize, though. So I mentioned already we have some benefits in terms of taking things offline, and that's going to increase your availability for your applications because now users can access their data not just when they're connected to the network, but at any point in time. But we actually see other benefits as well. When people are working online, that data, they don't have to access the data set on the server for every single call. Instead, they have a situation where we only need to move changes back and forth. So for a large number of scenarios where users have a lot of reads and not that many writes, you're going to see a large reduction in network traffic, which could also mean a reduction, in many cases, in bandwidth use and accordingly costs. And that's where we come in. We're saying, OK, so that lowers your costs for servers to service clients. And at the same time, now you have the advantage that that data is close to the user. So you have a reduction in latency, which means you can provide, in many cases, a much more responsive user experience or a richer experience because you don't have to be afraid to load that data to provide that experience. So, for example, you can go with scrolling instead of paging or other things along these lines. Then we also see that once we have synchronization, it doesn't just have to be syncing to a server and a client. You can start to say, well, clients can sync with each other too. And this provides a lot of very interesting scenarios, especially for mobile worker applications, or if you have a business app you want to take offline, or if you have users who might want to collaborate where they have a local network. You could even see this for some social networking applications. So we want sync to also work peer-to-peer, and absolutely the framework will handle that case as well out of the box. So you can also sync between clients, and in fact everyone's a peer, and it's full multi-master synchronization. So as I mentioned before, the sync framework solves these hard problems. We look after conflict detection. We ask you how you want to resolve your conflicts, or we can resolve them automatically for you according to policy. We handle different connection and storage errors and ensure consistency of your data. And we handle a lot of other conflict and other corner cases relating to correct data synchronization without loss. As I mentioned, we support unreliable networks. And this is all very straightforward to use for you. The logic is bundled up so that you don't have to worry about a lot of detail. You just work on the implementing something to talk to your store. We call that a provider. And we do the rest. And at the same time, we know it's a goal to be performant, and absolutely that's something we focus on as well. So I mentioned a bit of a provider. So we want the framework not just to work with particular endpoints. You see many synchronization solutions that will say, you can sync your data wherever you want, whenever you want, as long as you put it in my store. But that's not a reality for a lot of people. They have a store they already have existing, or a store they want to use for other reasons, and they want to be able to synchronize the data from their store. So we introduced the notion of a sync provider. And what a sync provider is an extension point that's going to expose your endpoint to the sync framework. So a sync provider provides logic for things like loading data from your store, saving data from your store, and it also encapsulates the logic. For example, if you want to resolve conflicts in a particular way, we can ask your provider how it would like to resolve conflicts. So you can imagine writing a provider for a number of different endpoints. For example, you could write one to a service, say for some web storage. You could write a provider that talks to a desktop application store, like say you want to get mail or contacts out of Microsoft Outlook. Or you could write a provider that talks to a device, something like digital camera, music player, or any other device you can imagine. At the same time, the sync framework is agnostic of protocol. So in general, we just require that you're able to move changes and metadata from one endpoint to another endpoint. We aren't concerned about how those changes are moved. That's the domain of the provider. Instead, we just want to talk to a provider that's local, and you can handle moving the data across. Now, if you want to separate doing some work on on one machine and some work on another machine, spreading your provider across, there's support for that in the framework as well, though that's a more advanced scenario. At the same time, though, sometimes people do want to use a well-known protocol for interoperability. And in that case, we have this protocol called FeedSync, which the provider supports, or rather the framework supports, and I'll talk about that a little bit later. And I mentioned before that we support arbitrary topologies. Now, what does that mean? Well, if you think about all the different endpoints in a synchronization scenario, they form a topology of connected nodes. And some of those may be a tree, some may be a star, or some may be a peer-to-peer mesh. So, for example, it could be something with loops, or it could be a fully connected mesh. And we want to make sure the framework works across all those different endpoints, because oftentimes it's not easy to make things only be a star. And that's where a lot of sync solutions fall down, because they can start to introduce false conflicts when there are loops. But we handle that correctly. This is very useful if you want to not worry about what your topology looks like and just think about your scenario and who should sync with whom. So how does the framework come together? Well, we have a number of different layers here. So we have a few end-to-end solutions. In particular, right now, shipping in the CTP, you'll find sync services for ADO.NET. So I said we support arbitrary data endpoints, but at the same time, a lot of people say, well, that's great, but I know where my data is, and it's in a database, and I want to talk to it using ADO.NET. And in that case, we have built-in support that says, okay, I know my data is in a database, and I want to talk about my data in terms of ADO.NET terms. I want to manipulate data sets. And out of the box, you can really easily build sync between two different relational endpoints. We also have something we're thinking about called Project Codename Astoria Offline, and Pablo will talk about that a bit later. Then underneath that, we have a set of in-the-box providers. a relational provider for syncing relational data. That's used by sync services for radio.net, though you can use it outside the context of that stack as well if you like. There's a built-in file sync provider. A really common scenario a lot of people want is I have files on this drive, I have files on somewhere else, say on a network share or another drive, and I'd like to keep those two in sync. If any of you have downloaded SyncToy, which is a power toy we have for synchronizing folders on a particular machine, and you'll notice that in the newest version that it supports various things like unplugging and replugging USB devices and is a lot more robust in terms of handling scale scenarios. What we've actually done is replace the sync engine that was in the SyncToy with Microsoft Sync Framework, and it's using the file sync provider underneath the covers. We also have support for FeedSync, as I mentioned. I'll talk about that a bit more later. And then below that, we have a bunch of functionality for people who are writing providers. Things like a metadata store for storing various synchronization metadata, and support for writing various types of providers. And below that underlies a common metadata substrate. So I'm not going to talk too much about this today, but we have an open space talk later where I would love to talk about this. I'll give a chalk talk, and we'll go through a little bit more about how the synchronization metadata works. And for now, you should just know that we assign things metadata very small, and that allows us to keep track of things like who knows about what changes and where conflicts occur. So bits are going to come out in Q308, they'll RTM, but we have a CTP that's live now. This is CTP2. We just put this up yesterday. And we're also committing that we'll have a mobile CTP at Q308 when the desktop framework RTMs. So the framework supports development in multiple languages, pretty much anything you'd like. We have a managed version of the framework that'll support development in C#, VB, et cetera, and a native version of the framework. So if you want to develop using C++ and call into a COM library, we support that as well. If you're interested in other platforms, come and talk to us. We have licensing available. So I talked already a bit about what synchronization is. I just want to highlight a few more of the scenarios you can do with sync. Because some people come to me and they say, wow, Neil, that sounds great, but I don't actually want sync. What I want is roaming. Or what I want is collaboration. But these are actually all different words that refer to synchronization. So, for example, offline is the scenario I was talking about a lot already, where I have data on a client and data on a server, and I want to keep those two endpoints in sync. But we also have peer-to-peer scenarios or roaming my data. So that could be my data, and I want to move it between my laptop and my desktop. And this is, again, a synchronization scenario, except the topology looks a little different. For example, you can imagine some loops. I could sync my data from my laptop to my desktop PC to another laptop or, say, a mobile device, and then back to my PC or my desktop. So you can have more interesting topologies, but it's, again, a sync scenario. And a third scenario that a lot of people think about is collaboration or sharing. So I might have some data, I want to share it with my friends, then they can manipulate that data, we'll all get each other's changes, and we can collaborate. This is also useful in business scenarios. For example, you can imagine an offline field worker scenario. For example, a bunch of consultants go to a client site. They have a data set they got from a central server, but they'd like to work on that. They're going to be disconnected for some time, and then they'll sync it back to a central server. So these are all actually sync scenarios. But I've sort of talked a lot about concepts now and what this can do, but I think I'd like to make it a little more concrete and show you sort of the sync framework in action. So I'm going to ask Liam to come up, and Liam's going to give a demo showing contacts synchronizing use of the framework. Good?
Thanks, Neil. So specifically, the demonstration why I wanted to go to today within the Sync framework is a specific scenario that you'll see in a lot of enterprises. It's the idea that there's all these different islands of informations out there. So for example, you might have an Access database. You might have an Excel spreadsheet. All these different users have islands of information, but there's no real good way to keep that information in sync. And the same thing is true. Let's go forward here. The same thing is true, perhaps, in your own personal life. You might have your own contact information. You might have some of it up in Hotmail. You might have some of it stored in your Outlook folder. You might have some sort of line of business application where you keep that information as well. So what I'm going to do is show how we can use the Sync framework to create these providers that Neil's been talking about, tie all the different data sources together so that we can synchronize them, regardless of whether it's offline or peer-to-peer or collaboration or whatever we want to do. And then specifically, as you can see here, here are the key aspects that you're going to see in our sync frame application. There is an orchestrator, the sync orchestrator. This is the application that actually says, okay, go and synchronize. And it calls a number of different sync providers that talk to the various different endpoints. If we go back, we can see in my example, which I'm going to go through, it's a contact example where I'm going to synchronize contacts from Hotmail to Outlook to Windows Mobile and have all that collaboration and come into play with the sync framework. So let me switch over. And right here you can see I just have my normal Windows Live Hotmail account, and I can sign in. Connect in. And what I'm going to do once I get in is I'm going to just put in a new... Oh, let's try that again. Here we go. So log in, and we're going to enter in a new contact into this store. Give it a second. Looks like it's taking a little longer. That's all right. Well, while it's loading, let me show you a few other pieces that we're going to walk through in this demonstration. Down in the right-hand corner here, I have my sync framework application. That's the piece that is going to call all the different providers. So now let's come up. Let me click on contacts, put in a new contact, say John Smith. Put in an email, test@test.com. Let's put a mobile phone, and save that contact. So of course, here's that island information. I have that contact here, but what happens if I want to move it somewhere else? What happens if I want to bring it down into my Outlook contacts? Well, as you can see right now, I don't see that contact, but if I were to right-click on my sync framework application, initiate sync, what it'll do is it'll go out, talk to Hotmail, and it'll grab that change that has been added to it, bring it down to my Outlook folder, because I actually have a provider for that. And of course I can go in, take a look at the information. Here's all that contact information. Let's make a little change here. And let's add a fax number. And save that change. So we can see that we've now updated at this other place. So we've shown this offline scenario, taking the data offline. But what happens if I want to collaborate? I also have a line of business application that talks to my local SQL Server database. And that just happens to be over here. And if I look at the customers, during my synchronization process, it had previously brought down that John Smith, as we can see here, as the test and the telephone number. But I haven't actually synchronized to update that. I haven't collaborated with that database. So let me take that over and synchronize that over. Take that change. Did I hit on the right button? Take that change and bring it over as well. And let's see, did I actually get it going? Oh, I did. Okay, it was just too quick and didn't see the window go over. But I've actually seen how we've now taken the change that was in Outlook and brought that over as well. Well, that's all fine, but now I also have a Windows mobile device that has a contact management tool in there as well. So let me synchronize that to that. Well, unfortunately in this current application, I hadn't added that new Windows mobile provider. So I'm just going to close this down. And I'm going to open up a new synchronization application that I had just written. This is my version 2 of my application that allows me to go to Windows Mobile. You can see here's my Windows Mobile. I don't actually have that contact yet because this is just a new provider. I've never actually talked to it. So let me hit on synchronize there. And it will get that change, and we'll bring that down to my Windows Mobile device as well. Here we have it. It's been brought down to it as well. And let me just open it up, make sure, yeah, it has all the telephone number, the updates, etc. And let me just go back into Hotmail. Let's just see if we've managed to bring the information back up there as well. Yeah, well, the whole idea of the sync framework is that it doesn't matter what the data store is. We happen to write a provider that talks to our contacts, and we actually in the provider we created, we said, okay, here are the key fields that we want to synchronize, whether it's first name, last name, email, whatever. But I mean, we could just as easily have a calendaring provider created as well that synchronizes that information. So let me just go back to my contacts. Let me make sure that contact has been brought over. We can see, well, it looks good since it has that updated telephone number. And if I look at it, it should also have the fax number synchronized as well. So you can see, hopefully from this, that even though I have this application, it looks like a little tray taskbar application, it doesn't matter. You can embed this synchronization into your existing application now. It's just really a set of APIs that you can embed that takes all the complexities of synchronization and takes that away from you. So you don't have to manage it. We take care of all that difficulty, all the conflict detection, all the conflict resolution, all the things that are really difficult to sync. We've hidden that from you and embedded it in our API. So let me switch it back over to the presentation now. Oh, here's the, so next. You're up next, Neil?
Yeah, I'm going to talk about something new. Thanks, Liam. Am I good? Okay. So, yeah, Liam showed you a demo looking at contacts being synchronized. Yeah, the point is worth making again, though, that the framework isn't specific to a particular data type. We just chose to demonstrate contacts because it's a somewhat compelling scenario. We also want to make clear that that app running in the tray is just an app that's loaded the sync framework. It's not the sync framework. There's no long-running application associated with the sync framework. It's something you load into your application. So we said that we want to connect synchronization between arbitrary endpoints, and that a sync provider is this common interface that tells the engine how to talk to those endpoints. And we also have this common metadata format that sync providers use to interchange data. But sometimes that's not the level we want to interoperate at. Maybe we don't want to interoperate at the provider level. Maybe we want to say, I want to have a common protocol, and I want different endpoints to interchange data using that protocol. Well, that's something else we can do. And in fact, we have one such protocol built into the framework, and that's called FeedSync. So I mentioned a bit before that FeedSync is a set of extensions to RSS and Atom. This is an open format. You can find the spec on msdn.com. It's licensed under Creative Commons. And what that does is it takes an RSS and Atom feed, and it annotates it with additional metadata that allows a synchronization engine, not just the Microsoft Sync framework, but any synchronization engine supporting FeedSync, to interchange data and synchronize that data, multi-master, peer-to-peer. So what does a FeedSync feed look like? Like, how is it different from an RSS feed? Well, the particular data added is what kind of changes are the changes. So instead of being a static list of data as of some point in time, we need to record what changed since the person last saw this feed. So a feed is generated for each person. And that's going to have things like create, whether this change was a create, an update, a delete, where a change happened, because that's important for resolving conflicts, and when changes happened as well. So we can know what changes happened before other changes and what changes happened without knowledge of other changes. So we've got built-in framework for working with these FeedSync feeds. And the way that works is, again, we use the sync provider. So you write a sync provider to talk to your endpoint. And then you use something we call the FeedSync feed manager that lets you use your provider to produce and consume FeedSync feeds. So you can see here, too, that if you've written a provider, say a contact provider like we saw in the demo, you can use it for syncing provider to provider. But if you also want to use it to generate FeedSync feeds, for example, that you're going to supply through a web service, you can do that, too. And this is actually something that's fairly straightforward to do. And what I'm going to do is I'm going to come over here to my demo laptop in a minute. And I'm going to show you, make sure it doesn't log out on me, show you how we can take some providers out of the same demo that Liam used. It's actually slightly different. The version I've got here is posted on msdn.com/sync. You guys can download it. It's got a few different providers. They're just other contact providers. And I'm going to show you how I can generate a FeedSync feed of the providers without writing too much code. So we have this demo topology here. And it's slightly different, as I said, but it's largely the same thing. Again, we're going to have a bunch of providers. I'm only going to enable a provider that talks to Vista Contact Store. But again, it's just another contact provider. We could have done it to any of them. It's just the one I chose to use when I was working on the demo. and we're going to change it to generate a FeedSync feed. The code is very similar to consume a FeedSync feed, but I just wanted to pick one particular scenario and show that. So I'm going to go over here. Where's my little switcher? Are we good? Good. And what I'm going to do is I'm going to generate a FeedSync feed of contacts. So I'm going to generate a feed for everything that's in my store. Now, normally you would want to get data from the other endpoint so you can sync with it. But I'm just going to assume the other endpoint doesn't know anything right now. It's simple to extend this. So you can imagine a scenario, for example, where the other endpoint generates a FeedSync feed corresponding to the data it has in its store. It posts it up to a server. The server merges those changes into its local store, and then it generates a new client feed as a response. So we can imagine that the client feed that I'm going to make empty can't claim from some client, and I'm going to save the feed to a file, but we could also just use it to satisfy an HTTP request. So this is the application here. Now, I'll just give you a little walkthrough here. We have the sample here. This is the actual executable that happens to run in the tray. Then we have some unit tests for it. You can have a look at those if you want to download it. And some providers. This particular version has one that syncs to vCard files, one that syncs Outlook, another provider for Vista Contacts. So I'm going to use the Vista Contacts provider and the vCard provider, and I'm just going to use those for my example here. So the first thing we're going to need to do to this application is we're going to need to add a method here that generates our FeedSync feed. So I'm just going to go into the main executable here, this sync.cs, and I'm going to add this generate sync method. So I'm going to use some snippets here so you don't have to watch me type. And in this, we're going to need a provider. Now, I happen to know that all the providers are already loaded in this app, and they are loaded into an array, and they're used across the app from synchronization to synchronization. So we'll just grab one of those providers out of the array here. So I'm just taking a sync provider here, and I'm just going to pick one out of the array. I believe we'll actually end up with the either the Vista Contact provider or the vCard provider, but it doesn't really matter since they all use the same data format. It doesn't affect the demo because I'm going to sync the data between the different endpoints before we do this FeedSync feed generation anyway. So we're going to save this feed to a local file. I'm just going to stick it in a XML file in my root directory. And like I mentioned, we're going to use an empty feed to represent the client feed. So I'm just going to write an empty feed out to my file. Normally, you would just hand the client stream. It looked like a lot of code I dumped in, but really all I did was, in a single line, wrote a very ugly-looking FeedSync feed that has no data in it whatsoever. It just looks like an empty RSS feed with a different XML namespace. So then, as I mentioned, so we've got our empty feed, and now we're going to need to get a type called a feed producer, and this is the part of the sync framework that knows how to take a sync provider and use it to produce a FeedSync feed. So let me get the feed producer, and you'll see the first param I've already filled in as a provider. But I got these two other parameters that I haven't really talked about yet, an ID converter and a feed item converter. So these sound kind of complicated, but they're not. The sync framework, since we support arbitrary endpoints, we need an identifier to associate with every item on a particular endpoint. But we don't know what those IDs look like because your ID format may be different than someone else's, so we want to support all of those. So for example, you may use a GUID to uniquely identify an item. Someone else may use ulong. So we want to support different formats. But FeedSync, because it's an RSS feed, wants a string for the identifiers. So we need a type to convert between the different identifier formats that the provider knows about and that the feed knows about. And this is the ID converter. The other type is this feed item converter. And again, as providers exchange data, they use an in-memory object. We don't know what this in-memory object looks like. That's particular to a set of providers. They just need to agree on that. But when we put it in an RSS feed, we need it to be XML. So this feed item converter converts between whatever the provider's object format is, for data interchange format is, to and from XML. So someone would just write this and probably ship it along with their provider. So for example, if you're writing a contact provider, you might also supply a feed item converter for your contact format so people can convert it to some agreed upon XML representation of a contact. Now, I'm not actually going to bother with coding one of those up right here. I'll show you it, though. but I have one that I already wrote earlier, kind of like a cooking show. And I'll just load it up so you know it's like not fake. And all this does is our particular contact providers happen to use GUIDs to identify things. So you'll see a lot of code here in the feed ID converter that converts between GUIDs or global IDs, sync global IDs, which is just a format we chose to use that has a integer prefixing the GUID to and from those in strings. So I'm not going to spend a lot of time on that, but you can see it's fairly straightforward. The only one that may look a little hinky to you is this generate anonymous replica ID. So FeedSync has this notion of some endpoints may choose not to identify themselves. They may just supply changes. And in that case, we need to synthesize an ID for this anonymous replica so that we can interoperate with the framework. And in that case, we're supplied a couple of parameters about where and when the change happened, or rather when the change happened, but not where. So we just use that to synthesize as some entropy to synthesize an endpoint. So in this particular case, I knew that I needed a GUID, so I just took all the entropy I was handed and shoved it through MD5 and used it to generate a GUID, but it's not super important. And again, my item conversion is very straightforward. I literally just took the format that we happen to have as an object and just ran XML serializer on it and dumped it out. So you could probably be a little more elegant about that, but it'll suffice for the demo. So let's go back here and get rid of this feed producer sort of half call and fill it in with the rest of the stuff. So I've got my provider, and I'm also going to new up one of my ID converters and my feed item converters that I just inserted here. And now we can actually just write the code that generates our feed, which is very straightforward. It's literally a single call to the feed producer and says produce a feed, and I hand it my stream. So it's going to read from that stream what the existing feed is, merge it and use that feed to synchronize with that provider. And then it's going to use that provider to do a receive sync, and it's going to use that to generate a new feed. And it's going to write that out to the stream. So let's see if it works. But you'd say, man, I haven't hooked it up yet. And you're right. So I happen to know there's this method doSync right here. And that happens to be what gets called when you right-click and click synchronize. So I'm just going to go and put a call to my generate feed sync down here. We could probably insert it in a better place into the flow, but this will work for the purpose of showing you generation of a feed. And now I'll just go ahead and run the app. OK. Good, we're running. OK, so I've got this contact folder. This is Vista Contacts. I don't know. Some people don't know about this feature in Vista. There's this notion of a centralized contact store, so you can keep your contacts in a place well known to Windows. And that's used there's a contact manager for it and things like that. So I'm just going to create a contact, though. And let's say my name is Bill and my last name is Gates. And we'll just add my email address. And let's say my email is billg@microsoft.com, because everyone knows Bill's email address. OK. And so we've got a contact there. This is very similar to what Liam showed you. And again, I'm just going to run the synchronize method. I just brought up a different view. So sync happened. Fine. It's exactly the same as the demo you saw elsewhere. And if I went and showed you the vCard files, you'd see that those were also synchronized. But we already did that earlier. So let's go instead. Actually, let me show you an IE. So let me just go. And you remember I wrote that out to the we're not going to wait for that to load. We'll go to the root directory. And I'm just going to open up that XML file. So let's go. And all files. And there's my feed that I wrote out. And we can see that we generated a FeedSync feed. And it's got this sort of ugly serialization format, because I really just serialized an in-memory representation of a vCard. But you can see that we have this thing. It looks a lot like an RSS feed, but you'll see some extra data here, like we have an ID for the item, and we have a thing saying who changed it and when. And this happens to be the replica ID of the particular endpoint that changed it. You could probably choose a nicer looking replica ID than a GUID if you were going to be generating a lot of FeedSync feeds, but you might argue who's going to look at it anyway. And you can see the data. There's some fields I haven't filled in, and they happen to be empty. We could suppress those if we wanted. But you can see we can generate a FeedSync feed fairly easily. I just wanted to show you that with very little code, if you have a sync provider, you can also participate in this open protocol, which is really nice because you can think of exposing this via a web service or using this to document your interchange format for data synchronization. And other people, either using the framework or not using the framework, could interoperate with that format. Have a look at the spec for it on MSDN. I think you'll see it's something very straightforward to interoperate with, either without the framework or with the framework. So let me go back to my slides here. And I want to talk about something else. I'm going to have Pablo come up in a minute. But so we've sort of said, out of the box, the sync framework lets you take any data, including web data, and synchronize it between any endpoint, any data format, or any protocol. And then also, if we want to agree on protocol, we can use FeedSync and use that as our method of interchange. But what if we're willing to say our endpoint's a web service, we know what the data format is, or we're going to agree on that, and that our protocol is HTTP? So can we make it easier? Well, we think yes. And our answer to that is Astoria offline. So I'm going to have Pablo come up. He's just wiring up his laptop here. They not a lot of provision for 3 demo laptops, apparently. And I'll hand things over to you. Do you want me to get that going, or you're good to go?
I think it's working.
Okay.
Thank you.
No problems.
Hi, everybody. So I wanted to just take a minute or two to talk about Astoria offline. Some of you might have heard about Astoria. We introduced it last year. The goal of Astoria was to create data services for the web, like data-centric services. And this interesting problem space is very broad, so we actually were done with the initial thing we wanted to do. We're close to shipping it, and we're exploring now this space together with our friends from the Sync team. So short story about Astoria itself is, Astoria is about data-centric services. Services out there have many shapes, and they serve many different purposes. And depending on the nature of what you want to do, you want a service that is very specific to your particular problem space, or you may want to take on a more general purpose interface that allows you to reuse your client tools, your developer environment, and also to have a service that has a standardized interaction model. So Astoria kicks in that space when you want to create services that follow a particular pattern that is sort of very centered around data services. Then Astoria makes it easy to create these services, or rather the data services framework, I guess. It makes it easy to create these services and also to interoperate with Windows Live services and Microsoft infrastructure services that also follow the same pattern. They're all Atom Pub based, and they have a uniform pattern for URL formats and such. So what is the deal with offline? What's the relationship between these things? The nice thing about Astoria services is that once you make the decision that you're going to go with the data services framework sort of formats and protocols and so on, and you want to be compatible with the same services that are out there in live and such, then you've constrained the problem space. So problem that was very broad now is very more specific, so we can help more building applications of this nature. So what you can see, like the difference between the previous picture and this picture is, if I go back, it is an online-only experience. And it works great when you have line of sight with your database across the web. What we introduced here is a couple of elements. We teach the servers, the Astoria servers or third-party servers that are using the data services framework, how to enable their data sources to be sync-enabled. Second, we're teaching the data services framework itself, and we're assuming that other implementations also do the same thing, to speak FeedSync, so that you can have an interoperable wire format that is proper for synchronization purposes. And finally, we have a local client-side store using SQL Compact, our compact database, that allows you to download the data locally, use it there, and then whenever you have a connection, you can sync in the background. But in the meanwhile, if you don't have a connection, what you do is you just write a local application. You never talk to a server directly, or maybe at least not for the data that is local. You just write a local thing, and then whenever there is availability of connections, then you can go ahead and synchronize on the background. So let me just show this working. I don't know which computer is that. It's not that one. I think it's this one. Yeah, there. Okay, so I'll go through this real quick. So let me create a new project. I wanted to start from scratch, and I'll build a very simple thing just to make sure that all of the pieces that are involved are clear. In the next session that Mike Flasco will do on real-world RESTful data services, you can see a real application built around this. So I'm going to create a very simple console application. And what I want to do is I have running here, somewhere here, I have running a service, which is a data services framework service. For those of you that are familiar with this, this will look very similar to the ones you've already seen. In this case, this is a Realtor's application. So I have like listings, so I can say /listing, for example, and see all of the listings in the database I'm using right now. So the output is in atom format, which is the same format we use across all of our services. And I can collapse the entries, and I can see each one of this is an entry, a listing entry. And each one of them has like bedrooms, bathrooms, square feet, and all that. So let's build a quick application that takes this offline. The flow for this is, so I'm going to add a data service reference. Now, let me qualify this a little bit. This is very early, and this is literally an experimental thing we're building. So I'm going to skip a number of steps, and in fact, the way we want to create the data service experience is somewhat different from this, but this is like a proof of concept that we wanted to share very early in the process. So what I'll type here is the URL to the service, which is this guy, and say OK. So what happens now is a couple of things. So my project is set up for synchronization. This means all of the references and such are added, and also enough information about the service is downloaded to the client. So now I have metadata about all of the elements in the service, and I have a client-side set of classes that represents a local store. I also get my local database, which is a SQL compact database that I can use to store my data locally. So let's quickly go through, make like a real sort of pass over this application working. So first thing I want to do is I'm going to create the database, and I'm going to call this always. If the database is already there, then we'll just not create it again. Nice thing about having metadata is that if the application is provisioned for the first time, we'll just create the database and download the data from the server. So now what I want to do is I'm going to create a new instance of this object that represents my local store, where my entities are, and here I'll write a quick query. I'm going to say from the listing in db.listing, and you can see we have link integration against the local database, where, listing dot say bedrooms greater than more than 3. I want homes with 3 bedrooms. Select the listing. Now I'm going to just iterate over them. So right line. We'll put just the MLS number of rooms, and description. The nice thing about this is I get like a very nice object-oriented experience across the whole thing. So listing in query, and do this. So this is listing.MLS number, listing.bedrooms, and listing.short description. Okay, so let's run this thing. Great. I know. I always forget to do this. Let's tell this thing that I want this in my output. So we're doing a query, and we have no data down, because I didn't sync anything yet. So the server has a bunch of data, but there's nothing on the client. So what I'll do here is I'll tell the system that I already have a default replication profile. So assuming that I don't want to tweak anything, and I'm fine with the defaults and no filters and such, I can simply say synchronize from service, which will kick off the synchronization. And typically, you do this in the background, but in this case, I'm going to just block on this so we can see steps going. So first, this will sync with the service over HTTP. This works across the web and such. And then once it is done syncing, it will print the list of houses that I just brought down to the client. So you can see the MLS number of bedrooms, and the descriptions of each one of them. So I just synced from the server to the client in a very few lines of code, because we can make all of these assumptions about this. So just to close the loop, so now let's say I'm on the client and I want to make a change on one of them. So let's go here, find one of the listings. Let's take this one. So this is the ID of the listing, and this guy has how many bedrooms? It has 5 bedrooms. Okay, let's change that. So here I'm going to go find that particular guy, listing 1, for example. I'm going to say from L in db.listing. Again, I can use link also to find a particular one. I'm going to say listing ID, listing ID, there, equals the one I just grabbed from the server side. Select the listing, and I'm going to say first, because I know that there is that one by key. And so I'm going to make a change in it. In this case, I'm going to change the number of bedrooms and say it actually has 6 because I'm actually there and I just realized it has an extra one. I'm not connected now, but I want to make the change. I'm going to tell the system that that I just modified an object, so I'm going to pass this to the system, and I'm going to push the changes. I'll say save changes. Of course, when I save changes, I save it locally, but I didn't change anything on the server. I'm not even connected, perhaps. So last step is, so what I want to do here is realtors system sync, which is just a wrapper around the sync call, so we just make it easier for this particular application. And what I say is synchronize backwards to the service. Of course, we will have a single pass synchronized in both directions, just for the sake of argument. I'm going to go this way. So let me debug all the way to this point so we can see how things happen. So first, we'll sync down. There's nothing new to bring down, so that would not do anything. Then we'll print the listings that we have, and then we should, at some point, hit this breakpoint, eventually. Or not. Hello. Let's just do this. Actually, I'll do this so it goes faster. Oops. And let's just step through the whole thing so you can see. So first thing is I'm going to formulate this query, run the query. This will give me, let me run until this point now. So here's the output that we got before. And then I'm going to go find this particular object, change the number of bedrooms, tell the system to mark that object for modification, and call save changes. Now, at that point, the local application has the change on the database and is persistent. But if I go here and hit refresh, and go down again, this thing still has 5 bedrooms because there is no change in the server. Now, once I go over the synchronization to the service part, and we do that part of the syncing process, what we'll do is over the same FeedSync protocol, we push these changes back down to the server. And once we're done with that, if I come back here and refresh this, then now we have 6 bedrooms there. So the important part is, if you look at this code, there's very little that has to do with this. And the overall experience was very metadata driven. We leverage the knowledge that we have about the service, and thanks to that, we can make it very straightforward to build online and offline data services. Thank you. So now let me give you the fine print. So this is very early. We're exploring this space. Actually, it's very exciting to see that you folks find this interesting. But we're in the sort of exploration phase. We want feedback. We want to hear what you guys think, and we will go from there. Neil.
Thanks, Pablo.
Thanks.
Thanks. So I think you guys can sort of see how the sync framework, and when you start integrating into applications, it can really make things kind of provide some really compelling experiences. There's some other places we see the sync framework as well. Now, some of you may have seen Nigel's talk earlier on SQL Server Data Services. I'll review it really quickly, and they actually have they're going to do a chalk talk in the open space later. So if you haven't seen anything, or if you saw something before and you were quite interested in it, I encourage you to go there. I'll give you the details later. SQL Server Data Services is about Microsoft providing a hosted web-facing data storage and processing utility. So you can think of this as storage as a utility. And there's sort of 3 things we think about when we think about this. The first one is we want it to be able to support a lot of different applications. So we want an agile format. Specifically, we want to support a very flexible data model. It supports semi-structured data that are stored in objects. You don't have to declare your schema up front. It's very cool to work with. In the chalk talk, they'll actually be talking a bit more about those APIs, which is so I encourage you to go have a look at that. The other interesting thing to think about with SQL Server Data Services is you have a choice of protocols about how you want to work with it. Right now, in the closed beta, you'll actually see they have both a REST API and a SOAP API. The REST API, you can get some puts and modify your data and get it down in different formats, and at the same time, you can also choose to pull the WSDL and use SOAP and get a nice, integrated, if you're using .NET, for example, experience over that. But at the same time, too, the cool thing about this being a service is we can guarantee that this is going to scale out for you. So you just use as much data as you want, and we'll guarantee that that data gets scaled out, and also that data that's from the same group, they call it an authority, is hosted on it's geolocated. So you can see how this is very nice, right? You pay for as much as you use, and at the same time, will grow as big as you like. Now, we're still working on what the model for that is going to be in terms of the charging. It's very early, but we encourage you to have a look at this. There's also a hands-on lab. But if people are going to give us their data, they say, well, I want to be able to trust this thing. And we say, well, don't worry. Microsoft, in fact, already, because of our investment in Live and MSN, is actually one of the largest, if not the largest deployment of SQL Server. And we need to support those services with high availability and high uptime. And that's exactly what we want to take that know-how and use it to provide this hosted service to you so that you can host your service with that same reliability, uptime, et cetera, et cetera. So we're going to use our investments in SQL Server technology to back this. We have an SLA that we will provide, again, so terms will be such that businesses can rely on it. And again, we're going to effectively be providing a high reliable and secure service. So you say, well, where does Sync fit in? Well, this is one application where we definitely see Sync. So if you can imagine, we have a lot of different applications, mobile applications, client applications, web services that other people may be providing or other Microsoft properties may use. And they're all connected via well-known protocols, so REST, APP. And then we say, well, how can we connect all these different things? So one of the things we already talked about was ADO.NET Data Services Framework, or Astoria, and you could use that to provide your on-premise service. We can also have SQL Server Data Services that's going to have a common API and will provide a way for you to store your data. And then we can also have other Windows Live services. And how do these all connect together? Well, we want to provide a seamless, interoperable experience and at the same time allow people to take their data with them when they want and where they want. So if they want it and they're offline, they should have it too. So we connect all these things with Sync. And so this is a really quick overview, but I wanted to sort of talk a bit about SQL Server Data Services and how it fits together with everything else and how Sync brings things together. So we're coming to the end of the slides, so I wanted to go through sort of what we've talked about today, and then we'll have some time to take some questions. So first of all, I gave you a bit of motivation about why you'd want to synchronize. I introduced you a bit to the high-level concepts in the framework, what's in the framework. Then Liam came up. He showed you a demo of how a bunch of different providers with a common sync controlling application could synchronize contacts between different endpoints. Then we talked about FeedSync for the case where we want to agree on the protocol rather than just working with providers synchronizing. And then Pablo came up, showed you how we could build a highly integrated end-to-end experience when we're willing to agree on certain things. And then finally, I talked a bit about SQL Server Data Services and how it fits together with Sync. So now I'll take questions if people are interested in any questions. Any questions? No? Yeah, let's use the mic. Otherwise, folks at home won't.
I noticed that you had multiple adapters with the relational adapter. Now, what kind of databases would that support? Would that support the typical local access database, or do I have to go with the compact SQL Server database?
No, so the relational provider in that Sync Services for ADO.NET stack, that end-to-end solution, that'll support any database you can talk to using ADO.NET.
Okay,
so
gotcha. Okay.
That actually
as long as I have an ADO.NET provider, I should be able to talk to any relational, I guess. Database.
Yeah, so I mean, you're looking at not just Microsoft databases even, you're looking at the full sort of spectrum of where you might keep your relational data. Yeah. Okay. So there's actually people already using scenarios, I believe, Liam can correct me if I'm wrong, where I'm actually quite certain where they're using a mixed set of different databases and synchronizing data between them with great success.
It's true. And if you're interested, we have a theater in the open space at noon where we're going to go through some more specific examples. In fact, we're going to go through an example where we synchronize access up to the SQL Server Data Services as well. And that's just through the use of a provider talking to the access and another provider talking to SQL Server Data Services. So absolutely.
What about file synchronization? Obviously, you have an adapter for file synchronization. If I have a need to synchronize files through the firewall, is there a way to do that? I know you could base64 them, but is there anything else that you do in there which would automatically do it out of the box?
So right now, the file sync provider is primarily focused on endpoints that store files that can be talked to through standard Win32 API calls. So either a local file or a file on a removable device or a file accessible over the network via SMB. But you could also write your own provider that talks to the file sync provider and then transits data through a web service. The format that object, remember I talked about all providers have a common object for data interchange?
Right.
The one for the file sync provider is also documented, so you could write your own provider, just like we wrote different contact providers to a different endpoint. Let's say you have a store in the cloud and you want to sync files to it. You could use the file sync provider in the box to talk to your local file system, and then you could write your own file sync provider to talk to your custom storage. Does that make sense?
Right. And one last question. As far as atomicity and transaction credibility, how are you able to do that within the framework? I mean, you covered that, but
so when you get into the question of synchronization, that's sort of one of the dividing lines between synchronization and replication, according to some. Others will argue about the difference between those two things. But the position we tend to take is the sync framework works on a net changes basis. So it's not a log store and forward based solution, right? It's not an action sync. Instead, it's net changes. So when provider A supporting endpoint A syncs with endpoint B, it's going to send changes from A to B, and let's assume that A is sending to B. It's going to send changes that have happened since A and B last synchronized. Okay. So if there were multiple intervening changes, that won't get forwarded across. It's primarily a net changes sync, which actually works for a lot of solutions. I know, Liam, you've already worked with some people who sort of were asking the same things, and we sort of talked a bit about how they could.
Yeah, so it's something that we see a lot more, especially when you're working with the databases. You talk about the transactional integrity and making sure that you can kind of batch it together, so that if you have foreign key, primary keys, that you kind of batch them all up together in the idea of a sync group. So in the sync services radio.net, we've built it in so that you can do that. You can actually have tables be part of a sync group, and it synchronizes those together. If the transaction fails partway through, it rolls back that group. But it chunks it in parts together so that you can maintain that transactional integrity, but optimize in such a way that if that group gets through, that's great. And if it drops off, then I can just pick off where I left off.
So at the each item level, you are using the GUIDs to uniquely identify each of those elements that need to be synced?
Well, you need some identifier, right? I mean, it doesn't have to be a GUID. One reason we made sure we supported flexible IDs is a good example is the database scenario, right? You probably already have a primary key, and by definition, that primary key already uniquely identifies items in your table. So you can use that as your ID.
Okay, so it is not mandated. We could use any
yeah,
means
in fact, no, it's completely the opposite. We don't want to mandate what format we do, and we went to a lot of trouble to make sure you could use whatever format you want to represent identifiers for particular items in the framework.
Thank you.
Questions on the FeedSync. Is there any options to not use it or use something else instead? Thinking either like JSON or some kind of binary format.
So
is there an extensibility model at that
right
level?
now, FeedSync itself, I mean, it as a standard is only about annotating Atom and RSS feeds. You could think, though, it wouldn't the FeedSync stack. There's nothing magical about what we provided there. The producer and that consumer, they literally use all public APIs to talk to the provider. So you could use the framework yourself, and so let's say you wanted to generate, write a provider for your store, and then use that to generate a feed in some new format you want to make up yourself, like that uses, say, JSON as the serialization format. That would work fine. That's something you can do. And if we see formats that are gaining in popularity, that's something we would consider. If there's a lot of interest, maybe we need to provide a producer-consumer API for that as well.
Yeah, and just to go along with that, the whole idea of building provider is something that we don't want to have to be the only ones to do it. So we're trying to build more of a community around providers. So, we have it open so that if you want to develop one, you can do that. But we're also looking at ways where through some of our, code sites, we can provide a community where someone could perhaps put together a provider that does that type of thing, and the community can kind of add it, use it, and do whatever they want to with it. And that's kind of our goal.
Yes, I have a question regarding a story offline scenario. How is the config resolution implemented in that case?
question is how conflict resolution.
Yes.
So a story offline, like from the synchronization perspective, doesn't have anything special with respect to the sync framework. Like a story offline is mostly about tying up the scenario together. So once we find metadata and we pick up default synchronization scopes and so on, we just write that to a config file, and then we use the synchronization, the sync framework, which means conflict resolution and such works exactly like in the sync framework. You can write code to react to it, and the code can apply policies if you always know what to do, or can sort of call back into the user through some UI artifact to let the user resolve the changes. From the framework perspective, all we do is we notify, like we track the changes, we notify you about them, and then you can go react to the changes and resolve them or let them propagate or something.
Thank you.
So a lot of really great work, and obviously everybody understands got to start at the general, but also there's some specific scenarios like your demos that, like, do all 475,000 developers out here have to actually write an Outlook provider?
No, and that's sort of what Liam was talking about, right? So we know that there are some common endpoints that people are interested in providers for, and we're interested in actively, sort of considering which ones those are and what we want to do in that space. We also expect other people as well to get feedback from their users. Sync framework is compelling. I want to synchronize, and I want a provider to talk to your particular endpoints. So yeah, I definitely agree with Liam. We see a community arising around providing providers for particular endpoints. So it's absolutely not the case that everyone has to write another provider to a particular endpoint.
And like you say, we are at a start. We have a number of providers. We have the ADO.NET, we have a file sync provider, we have the FeedSync provider, and so forth. So we have to start, and we definitely, that's our next goal, make it easier with providers. But, we want to open it up to the community as well.
With all those options, how far are we from seeing an offline wrapper for Silverlight? Like a Dobear for Silverlight?
That's an interesting question. I mean, Silverlight is something that we think is interesting as well. We've been sort of working on this right now. As you can see, sort of our initial focus was on rich applications, either running on mobile devices or on laptop PCs or even on desktop PCs for collaboration scenarios. But Silverlight is something we think is an interesting technology, and definitely we can see some scenarios for offline in Silverlight as well. So it's something we're looking at. We don't have any dates or anything we want to commit to right now, but you can be assured that it's something we find interesting too.
Cool.
Any other questions? Okay, so I'm going to do some plugs here. So we're going to be down at the open space at noon in the theater, and Liam's going to show a demo. We actually have another demo, like he said, syncing access with SQL Server Data Services, so that's kind of a cool demo. Then if people are interested in learning more about the provider model or about how the sync metadata works or things like that, I'll be giving a chalk talk. I'm mostly looking to take your questions and respond to those, or if you want to take a deep dive into your scenario and see how the sync framework might work with you, I'm willing to talk to you about that. In fact, I'm quite interested to talk to you about that. Then also, like Pablo mentioned, Mike Plesko has his session on building RESTful real-world applications with Astoria, and that's in, I guess, the room next door. Are we in?
Next hallway.
Yeah. And that's at 11:45. And if you're interested in SQL Server Data Services, those guys are also going to be down in the open space at 11:30, and they're going to be giving a chalk talk. I'd encourage you to go to that if you're interested in that. If you saw Nigel's talk earlier, this is going to be a little bit different. It's going to be a dive into the APIs. I believe Jason's going to go and talk through a little bit more about what the API looks like that you're seeing in the beta. Okay, so thank you very much, everyone, for coming. I do appreciate it.
Thank you.